Okay, we have here our TEMU battery. We're just going to go ahead and do the repair on it and see if we can get some better performance out of it. I'm going to start by going back through and replacing the fish tape that I ripped out, but this time I'm going to leave the hole in the center. And that was the problem last time, is the holes didn't appear to be cut out of the fish tape, so they were just never put in, which meant when they went to weld, there was no metal contact, so nothing ever happened. I'm surprised. They must have an automated machine assembling these, I would assume. And most likely what happened is, there was an error in the cutting process, and then their machine probably wasn't set up to detect that error when it was welding. Would have been a nice feature, right? Unsuccessful weld, it would stop or reject the battery and have an operator inspect it. Obviously, they did not do that. So, let's see real quickly here what we get. Like how they're flopping around like that. So one of the things I will do to help prevent that is just take a clamp. I don't need to get on it real crazy. It's a big clamp, but I can do kind of 3 cells at a time with it. And I just very lightly push it in, just so everything's tight and doesn't flop around. We have... I'm going to set this to 3.3 volts, 5.3 volts, and see how it looks. Looks pretty good. Definitely a stronger bond than it was last time. Yeah, I'd say that's pretty good. Let's go ahead and do the rest of them. My welder works good, but it's slow. Might be something that I look into upgrading down the road if we end up doing a lot more battery repairs. It is ultimately important to make sure it's charged, otherwise you'll wind up with a weak bond, and that's what I'm waiting for, is for these supercapacitors to charge all the way up. All right. Let's throw this on the charger, get it charged all the way up, and then I'm going to throw it on the analyzer and see what we get. Let's go ahead and assemble it. I'm going to leave it outside of the case for right now. Safer. I did charge the battery and put it on the tester and got the exact same thing, 2 amp hours. So that's a problem. Didn't change anything when I attached the new batteries. Put it back on the tester, ran a high current test, and bam! Still, only half the batteries are working. So why is that? Well, I have no idea. Decided to take the entire thing apart again. Pulled all the nickel strips out. This way we can look at and examine the individual cells. Check them individually for voltage, weight, internal resistance. Unfortunately, this mechanical work is pretty much required anytime you need to inspect or replace an individual cell. Usually by the time you add the labor up to do the mechanical work, it's not worth replacing just one cell in a bad pack. It's usually worthwhile doing the whole pack at that time, because you're already paying for the labor anyways. I generally advise against replacing only one cell because it can create an internal resistance problem in the battery pack. Depending on the cells and the one you replace it with, you can go either a higher or lower internal resistance, and it can cause either the one new cell or the existing cells in that series to all work a whole lot harder, causing them to fail faster. Here we're getting ready to do some internal resistance testing. The pink battery is a brand new battery off the shelf, just to show what a good internal resistance would look like. And this one came out at 13.42. The battery in the TEMU pack came out at 13.58. So good internal resistance. Now these are the batteries that are unlabeled, and every single one of them are bad. Not 0 volts. One of these cells are going to be good, are they? Wow. Whatever they're doing, it does appear to be intentional. Here we're going to measure the weight of the batteries real quick and just see if there's any striking difference between the two. I have a suspicion that the dummy cell, we'll call it, has less material in it. So this is the good battery, 43 grams roughly. And that's the one that works. The unlabeled battery is 32 grams. That's a solid 10 grams less. Two different 18650 cell types were found in the same battery pack. Lithium battery packs should use matched cells. Same model, same capacity, age, voltage, internal resistance, and state of health. The unmarked cells had different construction and shrink tubing. They were also about 10 grams lighter, and none of the tested unmarked cells worked. The working cell was identified as a Murata US 18650 VTC6, datasheet rating of 3000 milliamp hours minimum and 3120 milliamp hours nominal, with a 4.2 volt max charge. Tested capacity was only about 2 amp hours per working cell. In a 10-cell 5S 2P pack, 2 amp hour cells equals 4 amp hour capacity. Healthy VTC6 cells should be about 6 amp hours. Which brings us to why I bought the battery. Their claim was 8 amp hours, and they were selling it for $15. I just know that buying the batteries themselves are way more than that cost. In fact, as mentioned in an earlier video, I can purchase the plastic battery housing for around $12. So an entire battery pack for $15 just sounds like a deal that's too good to be true. And it is. Now, is there a use case for this battery? Possibly. At $15, it does function as a battery, might work well for something like a radio or a flashlight, but you're certainly not going to be running any heavy-duty tools like a nailer or a vacuum or anything like that. Did you end up buying one of these packs? Do you feel like it performs similarly to what you've seen here? Guardian can rebuild these packs for you to bring them back to top performance. Please reach out at www.guardiannv.com.